In this video, we're going to look at Charles's law. So in Charles's law, rather than like in Boyle's law where we looked at pressure and volume, in this case, Charles's law looks at the relationship between volume and temperature. We're going to hold two things constant with Charles's law here. So we need to remember this is at constant pressure and at constant moles as well. And a reminder that moles is abbreviated as N when we're doing gas laws. So the relationship is a direct relationship. And so the way we would write that is that the volume of a gas divided by the temperature is equal to some constant value. And we don't need to work that out right now. But given that for any situation, given that this is true and this is true, that constant pressure and constant moles, the volume divided by the temperature is always going to equal the same value. The way we interpret this then further is that they're directly proportional. So let's think, for example, that if we know that V over T is equal to a constant, so if I increase my, let's see, temperature, then what happens to my volume? So if I increase the temperature of a gas, the volume must increase, okay? Because the volume over the temperature equals a constant. So if the temperature goes up, the volume has to go up for it to keep equaling this constant. And likewise, if I decrease the temperature, then what happens to my volume? Well, this must lead to a decrease in volume. Now, it doesn't have to be the temperature that's changing. You could actually change the volume. So if I increase the volume, and I'm wondering, like, if I increase in the volume, is that actually going to change the temperature? And for a gas, the answer is yes. So if you increase the volume, if you expand the gas, the temperature must be dropping if you're holding at constant pressure in moles for this to be true, and that's what happens. So like if you've ever had canned air and you spray it on your keyboard or something to clean it out, you'll notice the can gets cold. It's because that gas is expanding, and as it expands, as you increase the volume, the temperature drops. All right, so let's look at a mathematical example here in application. Okay, so as a law, this looks like V1 over T1 is equal to V2 over T2. This right here is Charles's law. And this works because we know that V over T for a gas in a certain situation is always going to equal a constant. That's what we said right here. And so we're just, changing, we're going from one volume and temperature set into another, maybe temperature, and then we're going to calculate, well, what's that new volume? So let's look at an example here. Let's say that we have 10, let's not do that. Let's say that we have 10 liters of a gas, and its temperature is, let's say 300 kelvins. We must use absolute temperature here, so kelvins have to be used. If you're ever in degrees Celsius, you need to convert it into kelvins for these problems. And we want to know, well, what's the volume going to be if I, let's cut the temperature. If I take my temperature and drop it to 150 kelvins, what's going to happen to my volume? So I'm going to solve my equation for V2. So V1 over T1 is equal to V2 over T2. Now I want to solve for this because that's what I have here. So to do that, I'm going to multiply both sides by T2. So that gets rid of that. Those cancel out. And I'm going to rewrite this now. So I'm going to write it down here actually. V2 is equal to V1 T2 over T1. So I just took what's right here and wrote it down there. I'm ready to plug my numbers in. So let's see, my V1 is 10 liters. My T2 is 150 kelvins, and I have 300 kelvins down here. So my kelvins cancel out. I'm left with liters. That's good. And so this is going to equal, if I do the math, if I've done it correctly, V2 is equal to 10 divided by 2. So it's 5 liters. Now let's ask ourselves if this makes sense. So we looked at the relationship up here, where if we, decrease the temperature, then we would expect the volume to decrease because they're directly proportional. That's a direct relationship between them. And here we see that we go from 300K to 150K, so it's a drop in temperature. We would expect the volume to drop, and it goes from 10 liters to 5 liters, so I'm feeling pretty good about this. That is our answer. So that's how we use Charles's law to do calculations.